Hello, everybody. If you can also see, I have the slideshow that we're going to be doing on this webinar up here. It says Advanced Projects with the ActivityBot. It's the purple thing, so when I'm looking that way, that's me looking at my own screen trying to control what's going on. And then also, I'll actually have a camera over here where we're going to show off a lot of the projects that we're doing today, too. Please do use the chat window and the Q&A. And so let me switch to the next slide here. If you have a question you'd like us to answer, there's a Q&A functionality, and we'll address those. Kate's online, Stephanie's online, a couple others here in the building are online to answer questions specific to what's going on. And if there's anything that they're not able to answer, then we'll bring it out and go from there. And I'll do my best to answer it. There's also raising your hand. So if you want to speak, there is that button. We'll do our best to get those answered and try to make this as interactive as possible. So that's kind of the format of the webinar. And again, just use those tools and we'll do our best to get your questions answered. Here's kind of the outline for the webinar that we're going to follow. We'll have things to discover on learn.parallax.com. If you're not familiar with it at all, it's where all of our tutorials and projects are hosted. And we've added content to it just this morning. And that's what we'll talk about after that. So just we have new tutorials. There's a little bit of a show and tell. So things that aren't there yet, but are going to make their way there in some way, shape, or form. And a sneak peek at what's in development, specifically for the ActivityBot. Some crazy cool ideas. So kind of once we get through some of the foundational stuff, where you could go from here, things that I've had as thoughts in my brain, but that may or may not work. Sometimes you come up with a great idea and it's just that, it's an idea. And when the rubber meets reality, never quite pans out. And sometimes they do, sometimes they work brilliantly. Then after that, so we'll do Q&A. We'll hopefully have a good discussion about ways to really take your ActivityBot and solve real world challenges with them, because I think that's what we're trying to do. We're trying to get students to learn a base set of skills and then apply those skills in a real world setting. Things like autonomous cars, autonomous factories, augmenting our daily lives and our productivity with things like coding and robotics are high in demand skills. And so those are the types of things we want to give to our kids in the classroom, and we're hoping that we're able to provide good tools for you to do that. And then just finally, just Parallax products and resources. So kind of at the end of the webinar, as we get to the end of our time, just kind of a review of what's available, what services and products that we have for everybody so that you're aware of what they are and where they are. So here's the who am I. I haven't done a webinar yet, so please excuse my discomfort with looking at myself on a screen. I'm not a fan. So I speak, I said I speak fluent education ease. My training and most of my work experience is in schools as a teacher and then as a school administrator. Parallax saved me from that school administration life, although I definitely miss being in the classroom. So anytime I get to get out and train teachers, that's pure joy to me, and I'm pumped that I get to do it again here in a couple of weeks out on the East Coast. I know enough about electronics to be dangerous. I've had no formal training in it. Most of my learning comes from blowing things up, and then learning what doesn't blow things up. So I've gotten better at that over time. And then coding, again, no formal training experience, but I've done a lot of it. Just so you're aware, when we have our BlocklyProp system, there are 3 of us here inside that are on the development team, and then obviously everybody in the company really supports that effort to build it into the product that we and our customers want it to be. In terms of like the way it appears and how it behaves inside your internet browser, because when you go to Blockly, you're doing it through something like Chrome or Firefox. I'm responsible for the code in the browser, and so that's often how it looks and feels to the end user. So with that said, occasionally I'll take requests, especially if they are requests that would lead to an improvement that would be beneficial for everybody. And like I said, just don't ask me to change the block colors. That's a whole long discussion that if you catch me when I'm not trying to make something else awesome, I'll explain why. But that's that. So that's me. Enough about me. Let's get to the meat of this. So at the end of the webinar, in a few days, we'll email out just a folder full of stuff for you. And that folder will include this slideshow and some of the documents and stuff, whether they're in process or some links and stuff like that. But anytime you see this link thing here in the presentation that I'm highlighting, that's actually going to be a link. So when you get this, you can actually go straight to it from there. And so, like for instance, this link will just take you to learn.parallax.com. And I want to show off the IR remote code, the line following. So basically the things that immediately follow the ActivityBot series. So this is learn.parallax.com. If you haven't been here, please go here. We pour our heart and soul into this, and it's free for you. So it's designed to help you work with our products. And we're working with the ActivityBot today. There's BlocklyProp robotics with the ActivityBot has kind of been the focus of what we've been doing a lot lately. But if you scroll a little bit further down, there's the IR remote. So this is, controlling it with the remote control you see in every hotel room you've ever visited. We sell those too, to go along with the robot. There's the line following. So this is a sensor pack that allows your robot. So it's these guys right here. You add those to the bottom of your robot, helps it follow a line. Oops, don't break my demo. And then there's this line following of color sensing. So all of these, if you click into them, are things. And then there's a couple of new ones here that I'm going to talk about in a bit. So these are all here. They're all available through Learn, and I got here by clicking on the ActivityBot picture at the top. And then the one that's not there, but somewhere else on Learn is these competition ideas. I haven't gotten a lot of feedback from teachers, but the couple teachers that I've talked about who have tried some of these really have had a good time in their classroom challenging their kids with these. And so if you mouse over educators, you'll see where it says contests. And if you click on that, you'll see some competition ideas. So things that work particularly well with the ActivityBot. Sorry, I'm scrolling up and down really fast. This individual pursuit race is one that basically you can use what's in the kit. I've talked to a couple of teachers that have kind of fashioned a bracket out of cardboard for this to work. But when you click into these, you'll see kind of the name of the contest, who submitted it, kind of what the objective of it is, and then the challenges, and then how to set it up, about the game. And so they're basically just rules, like little competitions that you can set up within your own classroom, or if you're an organization like a Boy Scout group or a nonprofit, or like a Girls Who Code group or something like that, and you want to set something up. You can use these same exact competition ideas with larger groups as well. They work just as well in the classroom as they do with big groups. So these are all here, and like I said, it's a great way to sort of cap off a semester or a coding camp, or however you've been using the ActivityBot within your organization.
Hey Matt, can I point something out about those?
Sure.
Those were written largely to be robot agnostic. You could do most of them with a BoBot or with a ShieldBot for Arduino. Some of you may have used those previous platforms before. And the one thing to look out for is just fairness of the playing field based on the different speeds of the different servos that are included in the kit if you end up in a mixed competition. Brian Davis has asked a question that you might want to answer live, Matt, while we're on the subject of the different platforms. Okay, so yes, the question of the robot shield with Arduino versus the ActivityBot. I don't have a ShieldBot in the room with me, but so the ActivityBot, I'll just put one up here on camera. Actually, this might be a better. Here we go. So the ActivityBot, the Arduino as shield is basically, it's a board and then the Arduino fits underneath it. The ActivityBot is, the microcontroller is different. It uses the Parallax propeller. So it's a little more capable a fair amount more capable processor, and it allows us to program it
in both Blockly and C language. And with the activity board, you actually get some additional peripherals that aren't available on the JukeBot as well, like SD card for WAV file playback. And there's a couple of things that are kind of cool about the ActivityBot. But we always have tried to make it so that our other platforms, like the BoBot, the JukeBot, that there are sort of equivalent activities. So you can do a little bit more with the ActivityBot, and you can program it through a couple of different tools, where the Arduino one, you have to use Arduino's tools to program it. Although Arduino's tools are getting pretty good these days too. And even I've seen some block-based solutions that, although I wouldn't call any of them complete, are definitely getting better over the last couple of years as well. So hopefully that answers the kind of the question about the difference between those platforms. And some of the ideas that you hear in this, well, we'll show the code for them. It doesn't mean that these same concepts wouldn't apply to other platforms as well. So yeah, definitely hope you stick with us, even if it's even if you're working with the JukeBot for this. So let's see. So that's what's on Learn. And then let's talk about kind of new stuff on Learn. And I'm sorry, I'm going to get through the slides pretty quickly so that I can spend a little more time with the demos. So on Learn, there's, if you, sorry, let me go back to Learn and show you this. So if you click on the hand, you can always get to the main page. And if I click on the ActivityBot, this BlocklyProp robotics with the ActivityBot, this is sort of the main tutorial sequence. It's the starting place for learning to work with, and it's kind of the quarter or semester of content in a classroom. And you'll see it's a pretty, like, if you could consider each one of these units or chapters as you go, so like the software, the circuit training, the navigation basics, navigating with ultrasound, visible light, and then there's also navigating with infrared headlights, or the infrared flashlights, and that's where the tutorial currently ends. We are going to add a chapter to this that takes these infrared headlights or flashlights in front and allows you to do something pretty cool with it. And something that we've had for both the Arduino JukeBot and the BoBot before, and now we're actually getting it published for the ActivityBot as well. The technique is a touch different. The effect is basically the same, but it's a cool application with what's already in the box. And so basically we're getting a new chapter to go along with this. So that's coming here really soon. It's written up. It's just kind of finalizing the editing on it. And then there's a line following edition as well. And so if you have like our 12 pack with the line follower kit, or you've had the line follower kit, there is a brand new page here. So line following with arrays, which is just a different way to code it. But then if you go through this and you code it differently like this, then that will then become a stepping stone for other things that you'll be able to do with it as well. So it changes your code in a way that makes your program possibly more expandable as well. So and the tutorial kind of talks about that at the end. And this is actually the springboard for what I'm going to use in the Smart Cities example that I'm going to show you in a little bit. But it's kind of based on that, using the array approach with line following. There's also the Pingdar project. Again, something that was published way back when with the BoBot, but now has been ported over to the ActivityBot. So I'm going to open that one up and kind of show you what's there. And then I'm going to demonstrate that one for you. So this is an example where we can use the terminal to actually display something somewhat graphical, even though this is just all text. You'll notice it's just asterisks and like underscores and stuff. And what it does is it creates a sort of radar-like display. And so let me switch over to that view for you, and then I'm going to show you this guy. So let's get there. And then this is, when you follow that tutorial, this is the code you end up creating with it. But I want to demonstrate kind of how this works. So we'll put this dude right in the middle here. And you'll notice that he's got the ping turret right in front. So this is an add-on kit. It comes in the 12 pack or if you just have your ActivityBots, it's an accessory that you can purchase for them. And so, and what it's doing, you'll notice that it's kind of scanning back and forth. And so let me open up the terminal, and then I'll reset that. Oops. Uh-oh, my terminal not happy. Oh no, I might have to refresh my page here. Hold on. Of course, every time you try to demonstrate something is when it decides not to work for you, right? It was working an hour ago, I swear. Oh, there we go.
It was working. I witnessed it. It's
awesome. There it is. Okay. So you can kind of see that basically out in front here, you see I just put my hand in front of the bot. And so, oh, what happened to all my Zoom windows? They all disappeared. But if I move my hand out of the way, you'll notice that now it clears up. And so this is kind of like a radar-like display, and you can kind of see that it sees stuff off to the side. Like it sees a box that I have just off the camera's view, and then me sitting over here on the other side. And as I kind of move my hand back and forth, it changes the view as this swings back and forth across. Is my camera still coming through okay? Just want to make sure
yes,
that
it is.
Okay. So I don't know why, but it switched to my main screen on me here.
I see both things.
Okay. Oh, there we go. Sorry, let me quickly re-put my windows back where they were. Okay, there we go. So anyway, that's a demonstration of this one. And again, this is a tutorial that just got published earlier today. So that's something that's available to you. And we show you how to code this up and how it works. And it's a pretty cool application. So the same robot, the same robot, one of the other applications that I'll show you, it's not published just yet, but it does you can do roaming the room with it, and then also scanning and basically scanning for whatever the closest thing to it is and driving to it. And I'll show you that on a different one here shortly. Now the next one I'm going to show you is one that also just got published on Learn today. And I'm showing it to you because it's probably one of the highest demand ones. In terms of, can your robot do this? It's one of the things that's most requested. And this is IR beacon seeking. And so what we've done is, let me switch views here. So I'm going to switch cameras back and forth. Don't mind me being awkward with the zoom tool here. So, quick aside, I'm supposed to talk about this later in the webinar, but I'm going to show it to you now because otherwise you might be confused about what you're looking at. You probably recognize the circuit if you've ever played with the ActivityBot, but this is the IR detection, the IR flashlights that's at the end of the ActivityBot tutorial. But you'll notice that I've soldered it down to something. This thing that I've soldered it down to is actually a kit. So if you were to go to parallax.com, like our store site, so learn.parallax.com, our tutorial site, but parallax.com is our store site. And if you search for overlay, what this is called an overlay board. And what it is it's a kit that basically gives you a breadboard that fits right over the top, or sorry, a solderable perf board that allows you to build a circuit board that plugs right into like your ActivityBot or BoBot, and then you plug that down. So some advantages to this is that now you have a permanent circuit. So if you're a teacher and you're demonstrating something, this might not be a way to go, because then once it's built up, you solder it down and you're done. You'll never have to redo that. Also, if your students are doing things like competitions where the robots might be traveling in a case or something like that. In fact, one of the reasons I've done this is because I've been traveling a lot, and it's just nice to know that my circuit's not going to fall apart on me. because it's just only in the temporary breadboard. And they're not very expensive, and they're definitely worth kind of worth their weight in gold, at least in as far as I'm concerned. And so one of the things that you'll notice is that almost all of my demos that I'm going to show today, I've done up on overlay boards. So that was just one thing I didn't have to worry about. And I wanted to show them off because I really enjoy using them. Plus, it's a whole nother unit you could do with your kids. It's a soldering activity. And so that's there for you. Like I said, hopefully you like it. But what we're going to do actually is going back to the IR beacon seeking. So basically what you're doing is you're sort of splitting the circuit for this in half. And I'm using the full circuit here, but you really only need on the robot, you just need these detectors. And then what we're going to do is we're actually going to put a beacon. So let me grab this so that you can see it. Put the box in the middle here. So this is the beacon. It's basically just one of the IR emitters with a smaller resistor so that the IR emitter ends up being brighter. And what's cool about cameras is they can see infrared. I don't know if you can see that purple glow to it when I turn it on, but human eyes can't see that, but cameras actually can, and to them it looks a little purplish. But this is the beacon. And what's cool about the beacon is the robot's going to go find it. So we're going to put this off to one side here, just off camera. And it's still on, okay, hold on. Switching cameras, because I'm still getting the zoom thing. There we go. Okay, so just so you believe me that it's there, I'll leave it just in view. All right, so there's the beacon, and the beacon's on, and it's emitting. It's emitting infrared, but it's emitting infrared in a very specific way that will then allow the robot to find it. So I'm going to take the robot, and I'm going to point it kind of not at the beacon and turn it on, and it should kind of work its way toward it. And it's going to make adjustments because, you know, control system, but, and there it goes. Oh, wait a minute. I apologize. I'm showing you the wrong robot. Sorry. This guy has the code. All right. So he's going to drive right up to the box, and I've added a little bit of an additional code that once it reaches the box, it stops. Because, and the tutorial explains this, the robot won't stop on its own. But if you notice, I've actually put one of our laser ping sensors right in front. Sorry, I'll stop the beeping. So you can see the purple cool light from this one too. Look at that. That's so neat. Anyway, this is our laser ping sensor. It's stop. It's the laser equivalent of our ultrasonic ping sensor. So the ultrasonic ping sensor does the whole echolocation thing. It sends a chirpy sound that is at a higher frequency than you can hear, and it bounces back, and it measures how long that takes, and that's how it knows how far away something is. The laser ping does the same thing with light. And the cool thing about the laser ping is it's a little smaller. You can use the same exact circuit that you do with the regular ping sensor, but it's a little smaller, so it actually works a little better in this application because it fits better on the breadboard for no other reason. I could have used the ultrasonic one just as easily here. It just my breadboard would have been a little more cramped. But the beacon's been a popular request. For instance, one teacher that I've worked with was trying to do a project where he had a drone fly in and drop off one of the robots to do a search and rescue type thing on the ground, and then after it kind of mapped out something that was inaccessible to people, or they wanted pictures of the location before they sent people in, something like that. They could have the robot basically drive kind of a big sweeping circle, take photos on the ground, and then he wanted the robot to get back on the drone so that they could pick it up and fly it back. But the biggest problem they were having was getting the drone getting the ActivityBot, which is what they were using to mock up this concept, to drive back onto onto the drone and load itself back on. And really what they needed was this type of application where the robot sort of seeks out a beacon on its own. And so what you're seeing is basically the robot, and see here it's just a little too off angle for it to pick it up. So one of the things I can do is actually maybe adjust those. You can kind of play and tweak with your sensors a little bit and see if you can get it to, there we go. There, it turned right towards it and lined it up. So anyway, remember at the beginning when I said you get these crazy ideas and you try them out and a lot of times they just don't work, or you're like they need a lot more tuning before they work? This one surprised me. This one pretty much went straight from my head to on the bot, and it just worked. And I was, honest to God, shocked. I never have stuff work that well, but this one did, and it's pretty fun. So it's a published tutorial, and it's not even a very long one. It basically the code for this is surprisingly short. Kind of explains what's going on, and then it talks about how this actually happens. So we're sort of taking and feeding the pulses that the sensor expects into one side of the LED, and we're changing the voltage that goes into the other LED. And so really the sort of analog behavior that comes from this doesn't come from the sensors on the bot, but the analog behavior is actually coming from the beacon, and then we're just taking advantage of that on the robot. And so that's really how this guy works. So that's that example, and when we get to the Q&A, or if you're asking questions about that now, then yeah, we'll do our best to, yes, oh, the question of why not have the bot do a 360 looking for it, and yes, that's exactly what it should do first. Interestingly, the range on this, it seems to be, I've tested it at as much as 6 feet because it's about all the table space I have here in my office, and it still seems fine. I'm guessing that we can, you know, if you had a bright enough LED, you could probably really push it with this. And so, yes, that's absolutely what you could do. So the example we showed just showed, you know, how to make the beacon happen, but add a ping to make it stop. Start by doing a circle until you detect something. Those are both, I guess, ways you would absolutely want to challenge your kids to like make this a more robust and useful application. Some of those things, like we give you the concept and then we want to challenge your kids to, challenge you and your kids to kind of finish it off or make it awesome. And so that's that. Also, we've added these things to the scope and sequence document. So for those of you that are teachers or just or using the ActivityBot and you want to see this in sequence, under our educator resources, so let me actually show you how to get there. You can go educator, mouse over that, and then educator resources and ActivityBot resources. And you'll notice that one of them says scope and sequence document. And so we created this because it was one that a lot of teachers asked for, and it's basically what it does is it just kind of maps out all the, sorry, I'll zoom in so you can see this, but it maps out kind of each unit for the ActivityBot, kind of what's involved, what the goals of it are, approximate amount of time it'll take, although I almost hate to suggest this because it varies so wildly depending on your situation and your kid's experience and whatnot. But and then it goes all the way across. So we've added now the beacon and the line following if you've got the accessory for it. So kind of each of these is units. Resources are linked here at the bottom. So it's kind of a one-stop document if you're using the ActivityBot 360 in a classroom setting. So that's there. Let me close this back out and close the beacon. I'll close this one too. I don't need it yet anymore. And so let's move on to the show and tell portion of our show today. Let me turn the beacon off and set him to the side so he doesn't interfere with other things I'm going to demonstrate. I had the beacon on and I was trying to do something else and it totally messed with one other demo. So anyway, the JukeBot, by popular request. This one's just kind of fun. So let's do, so he's going to sit here and not do anything until I push a button on my remote. So here he is. I'll put my microphone nice and close for you. So he's got a few, it's just like a jukebox. If I hit 1, 2, 3, or 4, it'll play a song. So if I press 1, get your groove on. So, and then I press 2, and I get another song. I'm sure it's copywritten, so I'll move to 3. Is 3 going to play something? There we go. You guys hear that okay?
I can hear it.
All right, cool. Blare it through there. And then what's cool is it's got roaming code in here too. So if I push the channel up button, he's going to drive right off the desk. So the slipper little dude. There he goes. All right. So that's the jukebox. We've linked the code in here. So we don't have a tutorial for him yet, but he's coming. But basically the ideas are, if you were to do the IR remote tutorial, and then there's also formatting WAV files. So we haven't spent a lot of time with this in Blockly, but it's something we actually do in our C code. Let me switch cameras here for you. So I can show you this. So the ActivityBot, one of the cool peripherals on it is, one, the earphone jack with the associated amplifier circuitry that goes with that. We also sell these speakers and mounting kits for the robot. They're just a nice fit. But then also, there's an SD card slot. And one of the things you can do is you can actually format, you can take audio files and reformat them in a very specific way. So if it has to have a specific bit rate, and it has to be mono, and it has to be wave, and you have to strip off the metadata, all things that you can do inside of a free piece of software called Audacity. And if you have, so if you've done any programming using simple IDE, so in the C language, all the tools are there. Basically, you can put the card right in your robot, and you can plug in your USB cable, and you can load the sound file. Blockly does not yet have the ability to load something onto the SD card when it's plugged into your robot. And so you would have to do something like go to Best Buy or Fry's or Walmart and just get a little SD card thing if your computer doesn't have one, and save the files on it. And so once you've done that, once the files are appropriately formatted, then once you're in Blockly, the code is actually really easy. It's just a matter of, there's just a wave play block. So anyway, that's there for you. So yeah, and that's all you have to do. You just have to basically load those WAV files to a micro SD card. So that's one application. And again, this particular jukebox uses the turret, although that's not necessarily required for JukeBot, or for a version. You could make a version of the JukeBot that just had the standard, or just had the ping in the breadboard as well. Really, all you need for this one is kind of the speaker and the mounting kit. Or, like I said, you could do it with earbuds too. Let's see. The next one I wanted to show you guys is, let me switch cameras, is the Seek and Follow. And again, this isn't a published tutorial yet, but it's on its way. And so we've kind of got the code worked out for this. It was kind of nice because it helped us identify a couple of bugs that we've since been able to work out. But basically what I'm going to do is put a water bottle here, and I'll put the ActivityBot here. And when I turn him on, the idea is that he's going to sweep back and forth, and he's going to see, hey, there's a bottle, turn towards it, measure how far away it is, and drive to it. And so if I put a second object in here that's maybe a little closer, the idea is that it's going to seek out and find the closer one. And so hit the reset button on here. And there we go. And there it is. So, and again, that's just kind of a cool application of the sensor turret. It's a really good lesson in just kind of the math that's involved in there. There's a little bit of trigonometry involved because it's got to figure out what angle it is and how much to turn. So it's a really good activity to just kind of work through, and there's a lot of learning associated with it. So that's that one. We also have XB tilt control. We have the code here linked, and then the controller code. this is one of the more popular ones we sort of get is people want to ask, well, how do I drive the robot? And the remote's probably the least expensive way to control your robot. But the problem with the remote is that as soon as you have two remotes, they'll immediately start interfering with each other. So XP radios are one way that using some software, you can put them all on different channels so they won't interfere with each other. And so the nice thing about this is it's a really pretty easy to understand example, but all it is we've got a sensor, like a 2-axis tilt sensor. So when I tilt it side to side, it's set up to make turns. When I tilt it forward and back, it's set up to drive the robot forward and back. And so the other nice thing about the XPs is that you can also sort of send additional commands. And so if you put like our gripper kit in front of this, and then you add a push button on your controller, now you can start telling the robot more things to do. Like you can give it commands, like maybe you've got a button that just makes it wiggle its tail or something, or turns on lights on the robot, for instance. Like you could put like our RGB LEDs or something on here, and you can have them like identify colors, or there's a lot of different things you can do. And then plus the other thing about the XPs is they're bidirectional, so you can send information back and forth. And so once, for instance, this guy can go measure something off in the distance and then report that back to the base station. And so those are all applications with the XPs. And so the XPs are great for stuff like that. Knocked my camera sideways there. There we go. Stop, come back here. All right, so that's that demo. And again, we're still in show and tell mode, so let's set that one off to the side. All right. And I showed you guys the circuit overlay boards earlier in the session here, but again, just a really cool, inexpensive way to make your circuits a little more permanent, but then also a way to really make them robust. And the cool thing about the overlay boards is they sort of make pluggable modules. You can unplug one and plug another one in. Great for competitions, great for classroom demos, great for, yeah, just making things solid. So next slide here, kind of a sneak peek. And the topic of this webinar is the idea of advanced projects. And when we start thinking about what are the requests we get, what are the things that we hear people are trying to do with their robot, with their activity bots, and a lot of them, a surprising number of them, boil down to this idea of, I want my robot to know where it's at. And the thing that immediately comes to mind when you're thinking of, like, I want to know my position, is everybody really quickly thinks GPS. And then the next thing they do you sell GPS modules? Yes, we do. We do sell GPS modules. GPS is great, but its resolution is particularly low. And so it's really pretty accurate, but it's not very precise. For instance, if I have a GPS module and I'm standing in a spot in the parking lot, I can move to the next spot, the next parking spot 8 feet over, and the GPS is going to tell me that I'm still in the same place. Because it can't really detect motion. Anything under like 8 or 10 feet is just not something GPS is capable of discerning. It's not that precise. And so when you're talking about robots that are only a few inches across, GPS isn't going to do you a lot of good until you start scaling this up. And so the ActivityBot's a great platform, but GPS isn't terribly practical for it. But when you start thinking about, okay, so then what can I do? Now we're starting to get into the challenges and things that really kind of get the creative juices flowing and help kids think about, like, how that is a problem. How do I solve that? And so that's really what we're trying to do. And I put kind of SLAM spaced out here, because SLAM is an acronym in robotics. And you can Google the topic and you'll very quickly find yourself swimming in Wikipedia articles full of calculus. But it doesn't have to be that deep. But really, what it stands for is simultaneous location and localization and mapping. So again, it's this idea of, does the robot know where it's at? And is it able to map the environment that it's in? Well, if we treat that as let's just help the robot figure out where it's at first, then yeah, there are ways that we might be able to help it do that. And then when it comes to kind of knowing where it's at, there's kind of a sensor component to it. So, you know, can the robot measure its location somehow with some kind of sensor? And then there's the idea of there's a memory component to it. For instance, one of the ways to know where you are is to know what path you took to get there. And so if you can know something about how you got there, then you can sort of deduce where you are. And so those are a couple of techniques that we can use to help the robot understand its location. And those really, if you start with that as a concept, then now you're looking at, these are some really cool advanced applications that we can do with the robot, just like, for instance, the beacon, just helping the robot get to a specific place. And again, that was a totally sensor-based thing, but it really still falls under this umbrella of helping the robot know where it's at and where to go. So I'm going to really quickly show you something we're working on. So when I started with this concept, the biggest base part of this is kind of this idea of starting completely in the memory-based realm. Knowing where you are by understanding what path you took to get there. And so what we've done is we're starting to draft out and trying to, the next thing we need to do after we get this written is kind of figure out where it fits along with some of the other things. But this is a little deeper dive into a concept called dead reckoning, which is exactly that. It's using, for instance, if I look at this, if you think about a game of checkers, I can, if I know all the moves that a checker piece took, then I can figure out what square it ended on. And then, and that's just a matter of adding a couple of numbers together to get there. And so that same concept can really be applied to, for instance, a robot in a maze or going around. And so then this leads to having the robot go, for instance, if you imagine the robot like on a tile floor or a checkerboard or something like that, then this tutorial will be one that'll help. Like, for instance, you'll be able to like push button 9 on the remote and help your robot get to the square labeled number 9 kind of thing. Just through kind of these same concepts of just kind of like knowing where you are by knowing how you got there. And then some things about fine-tuning the robot's motion to really help that out. The disadvantage of doing that is something called accumulated error, where, for instance, if you move around a checkerboard by always either going forward, back, or side to side, but all your movements are kind of 90 degree angles, well, if your robot only turns like 89 or 88 or 91 or 92, what will happen is after 10 moves or so, now you're 10 to 20 degrees off. And so like that error sort of just builds up over time. And so that's the disadvantage of using a technique like dead reckoning. And so that's where we would do something like, let's solve that problem with sensors. Can we really tune our robot, like fine tune it, make sure its motions are really accurate, and then can we add sensors to it to really help it dial it in? Like, for instance, really understand that I only went this far. Using, for instance, like the encoders on the robot or the ping sensor to measure its distance from a wall, or using the compass module to know, which angle it turned to, so understanding its heading. So this is content that after this webinar we are going to send you. Do understand that it is a draft. It will not look like this in its final form because, this is pretty much what came out of the mind of Matt over a couple of days. And so, this is, you're sort of seeing a tutorial in its rawest form, and then we'll go from there. So hopefully that helps. I'm noticing a question. So with the AB, in the Q&A right now, with the AB360, how can I locate and pick it up an object? So starting with first off, like for instance, if you know where the object is, then you could use this dead reckoning example to help it get there. For instance, if I'm here right now and I know that the white ball starts off in this position, then dead reckoning is a technique you would get there, use it to get there. There are, for instance, one other way would be, for instance, to sort of zigzag until you see something like an obstacle. In terms of seeing something specific like a white ping pong ball, now you're talking about something called machine vision or computer vision. And there are some modules that actually do that. None that we sell, but if it's a specific application that you're really interested in doing, I guess go ahead and email us at education@parallax.com and kind of give us a little bit of context. And there might be a module. There's a couple of things that we've already looked at, and we might be able to point you to it. And Stephanie looks like she grabbed that question, so perfect. So anyway, kind of along the vein of that draft tutorial that you guys are all going to get a copy of here, if we don't send it today, in a couple of days, maybe by the end of the week, I think. I was tweeting out, kind of teasing this idea. So upside down, here we go. This crazy looking thing. All right, so if you look on the camera view, we're going to call this a smart city. And so let me give you a little, like, what the heck is that goofy thing that you made, Matt? So what this is some intersections. Like, this is intersection number 1, and this is intersection number 2, and this is 3, and I think you guys are all smart enough. You know what numbers are, so I don't need to tell you. And this is the street. So you could consider these black lines like lanes in the road. I didn't mean to set this up like British driving, but the robot has to drive on the left side of the road because that's the way I put the sensors on the bottom of my robot. So anyway, that being said, what the robot here is programmed to do is it's programmed to go up to an intersection. And remember how I said, at the end, we added one more page to our line following tutorial that talks about using arrays. Well, there's a little bit of a hint at the end of that. One of the things that it challenges you to do is, hey, now that you have arrays, you have another, like some more options. You can like make a tier, like make a bar at the end of your line and have the robot stop on the bar. And so that's what this robot's doing. It detects like, oh, now all of my sensors are seeing black. So that signals to me that I need to stop. And so at that point, it recognizes I'm at an intersection. And once it recognizes it's at an intersection, then it makes a random decision. So kind of a 1 through 4. If I get like flip a 4-sided coin, if there is such a thing, flip a square. Turn right, turn left, make a U-turn, or go straight. So it's just going to make a random decision at every intersection, and then it's going to go to the next intersection. But there's more on this map. There's also these weird stripy things, and what these are, you'll notice that if this is intersection 3, all the roads that lead up to intersection 3 have that many stripes associated with them. And what's cool about this is I don't just have the line follower kit under here. I also have a wheel encoder from one of our old robot, like the ActivityBot Classic. So this is one of the wheel encoders, and I have the same circuit from that. But what I've done is I've actually set it up to be kind of like a barcode reader. So it actually is going to drive over this, and it's going to count 1, 2, 3, and then it knows it's at intersection 3. Right now, the program doesn't do anything with that particular piece of information, other than it beeps at you 3 times when it gets there. But that way, it kind of like knows, like, hey, I'm at this address. So again, going back to that question, how do you help a robot know where it's at? Well, tell it. You could do this with the color palette and a color swatch, like where Ken in the last webinar showed off his line following where it had a color swatch at every intersection and the color swatch told it what to do. This is an example. You could actually use a color swatch to say this is where you're at. And so you could have a color palette. You could, that's one way. Another way you could do this, you could use RFID tags. So we sell like RFID readers and tags. That'd be one way to do like a really big kind of complex map that it would follow. I've also got a compass module on here. So not only does it know which intersection it came up to, but it also knows which direction it's coming into the intersection. And so again, that's one more piece of information to help it understand where it's at. And so these are all kind of applications. And if you're thinking, wow, Matt, that's really cool, but that's not what streets look like. But if you think about it, intersections that we drive up to in our car, they all kind of look the same. They have a specific format and a specific, like the stoplight at Menlo and Lone Tree is going to behave the same way as the stoplight at 1st and 3rd Street. They turn red when we're supposed to stop. They turn green when we're supposed to go. And so there is as much to setting up the environment for your robot as there is to coding and coding and constructing it as well. And so those are things to think about too. For instance, this application, I'm going to stop talking soon, I promise. This application only works because like all of the lines leading up to an intersection come into it fairly perpendicular. It actually took me a little bit of time to kind of figure out how to get the curves just right so that the robot behaved when it was in the intersection, because it sort of dead reckons its way through it to make each turn. But anyway, I'm going to turn the robot on, and this might work. It might drive around for a long time because remember, every time it gets to an intersection, it's random what decision it's going to make, or it might just immediately turn to the left and stop. So we'll give this a try here. So go, robot, go. I don't know if you heard the 3 beeps. So it's going to make a U-turn at that intersection, and then it's going to stop. 2 beeps. Go straight through. So what's cool about this is you might just roam around for quite a while based on this. And so here, I'll see if you can hear this. But yeah, there were the 2 beeps for intersection 2, and now it's done because it was about to drive right off the table. So anyway, this is an example of kind of a smart cities application. And so I've taken this to this point, but I could take this a whole lot further. For instance, I could add the IR remote, and I could just say, from wherever you're at on the map, if I press 4, then your job is to navigate to intersection 4. Or something like that. And so now you have a whole like delivery model, or if you've ever seen those, you should Google like the newest Amazon warehouses they're building and how the robots basically bring the shelves to the people loading the boxes that get shipped out. It's that same sort of thing where you set up an environment to help automate things like delivery or something like that. So there's a lot of things that you can do, and really this is the line following kit and the compass and a bunch of electrical tape. So you can go quite a ways with something. You could spend weeks on this. I spent weeks on this. So your kids will definitely have plenty that they can challenge themselves. So the line sensor on the ActivityBot, this is a kit that we have, and what they are is there are actually 4, I don't know if you can see that. There are 4, they're called QTI sensors, and they're optical. And basically they're effectively measuring reflected light and returning a 1 or 0 to know whether it's centered on the line or the line's off center. And again, we have a tutorial that goes right along with that, and Stephanie's pasting the link to that kit into the chat so that you can see that. So that's that. We've also got things like I said, other ideas for marking location, like the color pal, reading swatches. You could, if you didn't want to go as far as the color pal, we have a light sensor. The TSL235 is really good at measuring light, and it's a really easy sensor to use because you're just basically counting pulses because it returns a frequency. And so you could just use different shades of gray, and it's sensitive enough that you could actually have quite a few different shades of gray, and that would easily tell you how many, for instance, you could use enough shades of gray to have distinct intersections there as well. Again, the RFID, you could use Hall effect sensors. You could probably mount the whiskers under here somehow and put stripes of tinfoil and have the whiskers drag across and do something similar to what I did. Like then it would conduct electricity, and you could count how many pulses you get that way. Using the ping sensor, for instance, triangulation, and in the doc that you'll see, like for instance, I'll scroll down here, but this idea that if you have two fixed reference points, then what the ActivityBot could do is it could measure, you know, I see this one and I see this one, and based on how far away they are, it should be able to roughly triangulate its position from there. So there's another idea that could go along with this. So within this, you could add, I could put a ping sensor on the front of this and have multiple robots go along and not run into each other. So you could have a city full of robots or a swarm full of robots. Again, use the IR remote to tell it which intersection it's responsible for getting to. And so the possibilities really here are sort of endless, but if you just start with that theme of helping a robot or help the robot understand like where is it at, and just think of that as a challenge, then it really opens up doors to advanced topics, discussions, applications, and just kind of a lot of fun trial and error that you know, there's some really cool problems to be solved here. So, all right. So we're at the Q&A portion. I've shown off a lot of cool things, but I want to answer specific questions you might have about this thing or any of these demos. So I'll, optical mouse for location help. So that's a concept called optical flow. And I have not tried it, and I've wanted to. So yeah, it'd take me a little bit to work through it, but it would be a case of you'd have to know what protocol, for instance, that sensor's putting out. And you wouldn't necessarily be seeing location so much as you would be measuring your motion. One of the things that the ActivityBot does have available, and let me open up a BlocklyProp project just to show you this. So like here's the ping dart, but if I go to robot, one of the things that the blocks available here is this robot encoder's store count. And so as the robot's rolling around, it's actually keeping count of how much its wheels have turned. So like I said, part of the reason I actually haven't tried the optical mouse is because I would actually get similar information just from the encoder counts that are already on the robot. And so it wouldn't tell me anything I can't already get from the robot. But like I said, it's a cool sensor, and I'd love to try one sometime. Yeah, so hopefully that answers that question. Any other questions? Let's see. No questions? Did I just answer everything so awesomely that nobody has a question? All right. All right. Do you think you have the ActivityBot speed up when it comes to a certain? Yes, you absolutely could. So for instance, yeah, the nice thing about the Color Pal, and I don't have one with me right here in the room. They're on the other side of the building. The Color Pal is interesting because you can actually get a lot of information from a color swatch. Color has three components to it. It has a red channel, a blue channel, and a green channel. And those are all pieces of information that you can get. You can have the Color Pal, like for instance, you could go to the paint store and go get a whole bunch of like different color swatches and put them under the Color Pal sensor, and you'll notice that if you use the, here, let me go to sensor here. Go to sensor and then Color Pal. There's the store color in, and that gives you one number for color, which if you use that, so for instance, if I store this in a new variable and I call this sensed color, and then what you can do is under values here, you can say, I'm gonna need two more variables. So I'm gonna get, oops, let's call this red channel. Something like that. And then get that from sensed color. So here you go. So what you can do is you can read a color and then store it in this sensed color thing, and then you can get the red channel from it, or the green channel from it, or the blue channel from it. And you can even do something like, for instance, you can get a comparison. So you can, under values here, you can compare two colors and see how closely they match. So like 0 means they don't match at all, 255 means they're an exact match. And so yeah, you can actually pass a lot of information with a color swatch, and then tell your robot to do anything based on that. Speed up, slow down, make a left turn, beep, do a dance, anything really. When will Wi-Fi be available with BlocklyProp? When we're done testing it. So we have the blocks. They're there. They are. It's such a large thing. It's taking us a very long time to test them all, to make sure they work the way we expect them to, that they're not going to give our users a headache when they try to use them. And unfortunately, they're not going to be as simple in a lot of respects as some of the other blocks are to use. There's going to be a little bit of complexity that comes with their use. And obviously, it's going to take some tutorial support as well. And so the technology and the stuff is absolutely there. And if you're really brave and you want to play for it, there is demo. And I don't know if, Stephanie, you want to address questions for individuals on demo. Demos, it's kind of demo if you dare. Demos are testing site where things that will be in the future are now. And you can play with them with no guarantee that it will work for you. Because it doesn't always work for us. Yeah, so Wi-Fi is definitely coming, and I apologize that it's been a long time in waiting. And then unfortunately, it's still going to be a little more time in waiting. But yeah, once Wi-Fi opens up, there's kind of an endless world of possibilities there, because you get all kinds of cool applications that could come with that. No, these are great questions. Let's see. Is there a way to know which direction? Yes, it is. So the encoder count, so Carol's asking, do you know which direction it traveled based on the encoder count? And the answer to that is yes. Because if, for instance, let's say the count is at 1,000, like right wheel's at 1,000, left wheel's at 1,000, and it rolls 10 ticks backwards. Well, now it's going to be at 990 each. So the left and right are going to be at 990. And if it rolls forward 10, it'll be back at 1,000. Forward another 10, it'll be back at 1,010. And so the count will increase, or it'll increase for forward movement and decrease for backward movement. Where it gets a little tricky is if the wheels aren't moving the same amount or the same speed, then you're going to have to get a little fancy on it. And so now you're looking at measuring the length of arcs and involving some trigonometry potentially. But I absolutely challenge any of you math people out there to look into that, because I think there's absolutely I think we could really do some cool go to XY stuff like we have with the Scribbler robot. That would actually, go to XY would actually be fairly easy on the ActivityBot as well, just a little lower resolution than the Scribbler. In fact, about 10 times lower. But nonetheless, absolutely possible. So let's see. So should you be able to use an XY coordinate to grid map out certain pathways? Yes, that's kind of what we're absolutely doing. And so when we send you that, helping your robot know its location, or that document, and it talks about dead reckoning, that's really kind of, it's all about that idea of having your robot move in a coordinate grid. So yeah, these are great questions. Please keep asking. Let's see. Any others? Oh, I haven't saved my project. More questions. It's actually after 4. We're actually past our time, but I'm comfortable staying on for a little bit longer if you guys want. We still have 36 attendees. What I'll do really quick is I'll go through the last slides, so Kate doesn't get too mad at me because I haven't gone through the last slides yet. She won't get mad at me. So anyway, we do have, so the product line we offer, we have the ActivityBot 360. The BlocklyProp starter kit is kind of like your treasure box of sensors. And so we haven't marketed this a lot lately, but really when it comes to like all of the different cool advanced things, this is a really cool thing, one on its own, but it's also a really nice complement to the ActivityBot. And so like in a classroom setting, maybe picking up 1 or 2 of these, it's not like you would have like all of your kids use all of these sensors. I think that would be pretty expensive, but having sort of like a checkout system in the classroom, like, hey, I want to try this out. Well, here's kind of the smorgasbord of sensors, if you will, in the BlocklyProp starter kit. There's also the Flip Try It kit, which if you're looking into getting into like coding and electronics, but robotics are just a little beyond your price range, or just, you know, it's maybe a lower point of entry to start, then the Flip Try It kit is a great solution. It's a little lower cost. Plus we also have 12-pack class sets that we're starting to work out now. So that are sort of like the ActivityBot is a 12-pack plus. It's kind of like a turnkey solution for your classroom, because it comes with, like, the ActivityBot one comes with like, not only does it come with the ping turret kits and the QTI line followers, but it also comes with like rechargeable batteries and chargers to go along with that. And then the STEM sensor class pack, again, all about sensors, and you get 12 of each. And then the security project is for, you know, if you want to go down kind of like that, you know, security, biometrics, hacking, cybersecurity, there's a whole bunch there. So lots there. We've also, if you haven't found us on Facebook yet, please do come join. We have the Blockly for Microcontrollers group, which is a pretty active community. I'm personally not a Facebook person, but I do check in with it once in a while. Ken's pretty active on our Facebook group, and a lot of our community members that are joining us here in this webinar are also really active on there. And so I've seen some just really cool projects that people do. And so if you're looking for inspiration, it's a great place to look. And also to ask questions too. I mean, it's just, Facebook's kind of a one-all be-all platform, and it's great for people to just have great discussions. We have our educator hotline that rings, and a whole bunch of our, it's funny, we get a hotline call and all our phones go off. So we're gonna get you squared away if you call our hotline. Numbers right there. It rings a whole bunch of our cell phones, because we want to help you at the moment you need help. So when you do, give us a call. And if we can't get to you because time zone differences or something, because we are on the West Coast, so I know, like, the Pennsylvania call from 5 a.m. this morning, I wasn't awake for that, sorry. But we'll do our best to get to you as quickly as possible. So what's coming up next? We have a summer of learning, because we're doing cool stuff this summer, and we want you guys to be able to do cool stuff too, and get ready for your upcoming school year. So we're working through tutorials. Like you said, we added 3 this morning as a result of getting prepared for this webinar. We're going to try to add more projects. Additionally, we have we're wrapping up our Blockly courses, but we're starting up. We're going to try something new. We're going to do something called an Advanced Learning Institute, where we're going to take a deeper dive into things. It's we set that up for 4 days. 4 days. 4 days. It's so new to me, I don't remember the details. But we're going to talk sensors, protocols, and we're going to have it's an opportunity to create and work through projects. And the end result of this will be hopefully just you can walk away with tutorials, and then we'll publish those tutorials or projects or tutorials. And so we're really hoping to come out to have this Advanced Learning Institute and come out with things for the community. So that's my slides.